Hello, good afternoon, everyone. We are maybe we'll just started in let's say in 1 minute. Let's see if others will join us. So welcome everybody, and I'm excited to present this webinar with Rok and David. So the title of the webinar is From Scan to Street: How to Scanning is Shaping the Future of Motorbike Accessories. So we are thrilled to have you all here today. So my name is Marcio Knapek, and I will be the host for this session. Today we have two special guests with us: Rok Bagoroš, who is the co-owner of Bagoros Performance, and KTM Factory-supported stunt rider, and David Novak, who is the head of R&D at Bagoros Performance. So in today's webinars, we will dive into the fascinating world of 3D scanning and exploring how it's transforming the development of motorbike accessories. So we will showcase real-world applications, discuss the latest trends and innovations, and how they are shaping the future of this technology. So without further ado, let's welcome Rok and David. Thank you guys for joining us today. So we are excited to hear your insights and learn more about it, how 3D scanning is transforming the motorbike accessories industry.
Yeah, hello.
Thank you for having us. It's a pleasure. Yeah, it's a pleasure to be part of it. And yeah, I'm looking forward together with David to finally show you what we can do with your 3D scanners.
Thank you guys. Thank you. So fantastic. Let's get started. And to kick things off, Rok, could you tell us how Bagoros Performance was born and what inspired you to start this journey?
Okay, so Bagoros Performance is a company that it's actually, I would say, a pretty young company, 9 years old. And it started out of the garage, and we moved just half a year ago to our own facilities. So the story that we left behind our garage, and now we are a professional company, I would say. And it started out of the passion. Since I'm a professional rider for KTM and other big global brands, in my niche that it's called stunt riding. So it's actually riding with bikes performing tricks around the globe. And also we do a lot of YouTube videos and social media videos where we teach people how to ride. We show how we do tricks, and we also show how we build bikes. So through the years, I was building a lot of stunt bikes and developing parts for me. And sooner or later, people were asking us, hey, can you do some extra parts also for us and start to sell it? So we want to build our own bikes for stunt riding. And this is how we started 9 years ago out of a little garage that we rented to produce and weld and cut and weld our own parts with our own hands. And yeah, the company grew to a bigger team because it was more like a two-man band back in the day. Now we are in total 5 people. It's still a small company, but we are growing step by step, and technologies like 3D peel are right now a very crucial part in our growth as a company in general.
That's an incredible journey, Rok. So your background as stunt rider must given you invaluable insights into what riders truly need and want from their accessories, right?
Exactly, yeah. And unfortunately, I don't want to test, but it's part of the game. Crashing is part of the game. So really crash test all our protective parts that we develop for the bikes. So Bagoros Performance is actually specialized in developing and producing protective parts for motorcycles and also style parts to make the bikes nicer. And as I said, we started with stunt riding parts, but through the years, it became our smaller part in our portfolio of products that we are offering. And our main or core parts are actually parts that you can use on a regular street bike for the streets, and yeah, make the bikes nicer and also to protect them. So the stunt parts is just we kept it because there is still some demand, and also we still want to support the sport from which the company grew actually. So yeah.
So could you share how 3D scanning, the 3D scanning technology has impacted your product development process at Bagoros Performance, and on the how do you develop these protection parts for the bikes?
Definitely. It's still a pinch me moment for the last few weeks or let's say months. Why? Because the bikes, like one here behind me, uh, if I look into my bikes that we developed for my stunt riding a few years ago, it's all cut with the angle grinders and welded and so on, and not a lot of CNC machining was going on. So it's really handmade stuff. If you compare the previous bikes that I have in my other warehouse and the bikes that I'm currently using, it's a huge difference how they've been made. And just for instance, today we were modifying that bike behind me, and the sprocket didn't fit, and we quickly went to the CNC machine, which we have now since 5 months, and it's unbelievable how quickly we can change and adjust parts. And then when we come to the 3D scanners, it's another pinch me moment, because in the past we were needing to measure with a regular measure tape and try to hit the right measurements on the go, and it took us a lot of prototyping and a lot of error um, to finally come to the right measurements and the right prototype. And right now it's a matter of half an hour to 3D scan to 3D scan a certain part, or even faster, depends how big the scan needs to be. Uh, and the measurements are precise to the last millimeter, to the last, it's like one to one actually. So the David and the team, it makes their job way easier and faster. And it's, yeah, it's unbelievable. Now if you look closer, like we have pictures in front of us, so you need really to look carefully to see what was actually modified, because everything looks as it would come from the shop straight, but it's actually all CNC machine, powder coated, anodized, and it needs to look like the bike came like that. So this is the level that currently my stunt bike are being done. It's actually I would say pinnacle of stunt riding. It's hard to find this kind of builds. Not that I want to be now, how you say, cocky or something, but it's actually, yeah, it shows the whole passion and hard work from me and my team, each of us in his own, um, let's say, spectrum, and everybody is pushing in terms of showing what everyone is capable of doing, and it shows in the build that we did. So on the picture you have my brand new KTM 990 Duke, the newest stunt bike that we built, and it's sometimes I sit on the practice spot and I still just look at it, even though I have it for a half a year, it's still nice to look at it. And I just love CNC machining and good made products or accessories. And it's, yeah, I'm kind of a nerd in that. Yeah.
It's that's fantastic to hear. I'm sure our audience is eager to learn more about the specifics on how to 3D scanning works and its benefits. So, in the next session, we will dive into this the 3D scanning. So, besides customizing the motorbikes that Rok's uses during his performance, Bagoros Performance design and manufactures accessories that they commercialize. So here is a few pictures of one of the accessories Bagoros Performance manufactures. So the crash bobbins. These are essential for protecting the motorbikes during the falls and accidents, as Rok was explaining. So could you tell us more about the development process of these crash bobbins or other accessories?
Definitely, yes.
Rok or David?
So
Yeah, go
David
ahead,
is the
Rok.
man, is the magician behind that. So I'm more the guy to try out if it holds up the the crashes and so on, and maybe share some ideas. Definitely share some ideas how certain protection parts needs to be done from zero. But then my knowledge stops there. So that's why I have in a team the best possible people to add their knowledge, and in that case that's David. He's our head engineer. And yeah, David, you can maybe share how we develop from scratch with 3D printing and so on. Yeah.
So if you
Yeah,
broke yourself, it's David's fault.
Yeah.
sorry, I didn't catch that. I didn't hear
Yeah.
that.
No worries.
he didn't like to he don't like to
Uh,
hear that one.
so yeah, crash bobbins. Yeah, that is always interesting topic in regarding of R&D. Um, by crash bobbins, you need to be precise. That is the main goal you want to achieve. It means you have to be precise from the part you are developing till and the and towards the part you are developing on. It means you have very little space to produce something which will fit perfectly on the bike, which will look perfectly on the bike. And yeah, with 3D scanning, that is achievable basically. Because
and
if we
also
consider, yeah,
And also to mention, for us important number one rule is that the customer should not angle grind or cut or weld or what else. It needs to be 100% plug and play, and that makes the whole process very very complicated. So David
yeah,
and the team doesn't have really an easy job in some cases. Yeah.
yeah, definitely. Like I said, you have to be precise. You have to make a good product which will fit perfectly, which will fit easily on the bike. Like Rok said, it means our customer, which is not used to wrenching and everything, it must have the ability to put our product on the bike. That is absolutely necessary. So with 3D scanning, is that more or less achievable, like Rok said before, in 30 minutes for scan, and then in additional 2 days for for developing the part. And yeah, if we consider that we can do that in matter of hours basically in compared to when we
And,
were just measuring with calipers and measuring tools. That is
and
that is
comparing with the traditional measurement tools, calipers and tapes,
yeah.
how much time can you save on with the scanner?
It depends on part you are developing. It means by some parts which are very difficult to develop, we can save 1 or 2 weeks easily, and that is what we are looking for basically. That is something we want to achieve because we want to produce, develop as much as possible in shortest time possible,
And
basically.
and
Yeah,
it must fit, I think, the first time, right? So you don't want to back and forward with the prototypes and everything. So
that is our main goal, basically. With we want to achieve perfect fit with one prototype, nothing more, nothing less. If we can do that, and we do that now with 3D scanner, that is basically our wish, yeah, since the beginning, basically. Because if you consider that prototype cost us around 500 euros, and if you have to do 2 or 3 or 4 prototypes, then you know how much money, time, and everything you can save with 3D scanning. Yeah.
so basically, you're saving a lot of time and money with these prototypes
Yeah,
that
with that kind of development, you can save a lot. Yeah, definitely. Yeah.
Definitely, yeah.
thank you.
Like if you remember, David, many years ago, like yeah, when we measured with the calipers and so on,
Yeah.
it took us so
Uh,
many. Even then, we didn't have 3D prints, so it was done already from the
yeah.
aluminum. So as you say, it was
Mm.
so costly, it didn't fit. So I grew some gray hair, and we started from the beginning. And now with the combination of 3D printers, it's amazing. It's so quick and so efficient, time-wise and budget-wise. It's the thing to have. I don't imagine anymore to work with those tools in this kind of business, let's say, sector of motorcycle accessories. Yeah.
Yeah, definitely. Yeah. Yeah.
So
If
basically, you have all the tools to do in by your own or the development of this new product. So you have the scanner, the you design the part, and then you do the prototypes with the 3D
Yeah,
printers.
yeah. Now with 3D scanner, the 3D scanner was last piece of that puzzle. Now we have everything to produce everything, to develop everything, and produce everything in-house. And like I said, yeah, we are now that lucky that we can do that in a matter of days. Yeah.
Thank you.
Mm.
Can
Yeah.
you, I don't know, can you introduce us? We have prepared a little a quick video to show the process of this after scanning. Can
Yeah,
you
yeah, yeah, yeah.
explain the
I
video?
have prepared short overview of the main feature of the software that are really important or game changer in our development process. Yeah, yeah. So we can watch it. Um,
So the first
now,
time here, it's I think you are creating an alignment, right?
yeah, yeah. The first time is alignment, and why is alignment basically important? Aligning the part to specific feature is a basically crucial step. It's necessary to set the coordinate system on the part and use it later for other feature creation when needed. So it means you have to identify important features and use it in proper order while creating alignments. Yeah. Um, oh, yeah.
So then when you export this the final design to the features to your CAD software, it's
Yeah.
all the XYZ coordinate system
Yeah,
placed
yeah,
in.
yeah. That is when the part is scanned, the coordinate center is in the position of the scanner space, This is one of the reasons for repositioning the coordinate center. Now you can see that we have aligned that coordinate system with our x-axis, y-axis, and z-axis. To do that, we can use two planes and cylinder, and we have positioned coordinate center in the middle of that part, and that, like I said, is crucial later. Yeah. Then software also allowed us to modify and improve the mesh. If you want to fill the holes or some irregularities in the scan, feature. How do you call that feature? I don't
The few
remember.
holes.
Yeah. Mm, Fill house, yeah. And those are small steps, which is very easy achievable with Peel software. So yeah. Mm, Later, you can also, for example, a lot of times I need to remove signs or something like shown here. The KTM sign can be removed very easily with the feature tool, and it's very easy. Yeah, it's very easy to work with Peel software. So yeah, the next thing maybe is sketching. I want to show you sketching, how to sketch things and then later transfer it to something which is measurable later in CAD system. Uh,
So basically, you can use the software to work with the mesh file, so you can improve the mesh
Yeah,
quality, right?
definitely. Yeah, that
And
in
then
few
you can.
cases is that very important that you can improve mesh in software, because some parts need to be, yeah, like you said, improved, and yeah. Um,
And here you are remodeling the part, so you are using the mesh as base to extract the profile of the part.
Yeah, exactly. That is the first step. The first step of that is to extract the profile of the part using the cylinder, and the plane as a base. Then we simply use auto sketch tool and reposition the lines, place the constraints. You can use vertical constraints, you can use horizontal constraints, whatever you want. And once you are done, you just simply revolve that around the center line, and you have
A solid part.
solid part. Yeah, exactly. Yeah. So, like I said, now you put you have to put on some constraints like horizontal constraints, like vertical constraints, and it's very easy step with the auto sketching feature. That is, it's easy to work with. Yeah.
So basically, it's the tools that you can find as well in the CAD softwares, right? The lines, the tangents, how
It's basically the same. If you know how to use the CAD software, which you are using as primer developing tool, if you know using those tools over there, you will definitely know how to use those tools here in
modeling tools.
Peel. Yeah, in Peel 3D.
So basically, here you are doing the sketching, and then after the sketch, you can. I presume you are doing the revolve.
Yeah. I'm doing the revolve. I want to do a revolve feature of that part, because if you look carefully, that is the engine cover, which is cylindrical, and how should I say, for that kind of
Or
um, mm,
geometry?
yeah, for that kind of geometry, you need to use a revolve feature, and that's it. And once you are done with sketching, you can simply choose revolve feature, rotate it for 360, and you will get desired. Yeah, and now here is deviation. You can measure deviation between original scan and what you have drawn, and now we can see that deviation in that parts are 0.0 something. It's nothing. It's that
So
accurate.
you can do back and forth with your designing, so you can go back and then
Yeah, always. You can
realign,
go. Yeah.
redo your sketch.
Mm.
So you are creating
Mm.
something to protect that case, right? On
Yeah,
this.
yeah. In case of fall with your bike, there is a very easy way to damage the engine case
And
or clutch cage on the other side. So we are trying to develop parts which protect that lower end of the engine case, or on the other side clutch case, because it's very easy to damage them, and that's why our parts need to fit perfectly on that round cylinder to sit on it, and when the impact comes, we need to protect that aluminum part as much as possible. It doesn't matter if you damage our part. We need to assure that the engine case stays
It
safe.
doesn't touch it doesn't touch the
Yeah,
engine.
yeah, yeah.
So now I think we have another video where we explain we summarize the product development of for in Bagoros Performance. So
Marcio, we
Marcia,
don't
you
hear
need to
you.
switch. You just need to switch on the
yeah,
mic.
I am I'll mute myself. I'm sorry. Can you guys explain this behind of scenes of this product development, where the scenes that we could
Yeah,
see on
so
you?
you saw our R&D workshop, which is actually this one behind me. We use it for my YouTube videos and also for the videos and R&D for Bagoros Performance. We bring in a new bike. We 3D scan what we need, and then you saw some shots how the guys are designing the first prototypes, and then 3D print on the go. And the next step was our coworker was putting a raw material, in this case an aluminum, into the CNC machine, and then we of course CNC machine the part, and that's actually the part that you see on the picture. That's the so-called bar end mirrors, which replace the original ones, and it's something that's very popular in motorcycle industry, that to have those kind of mirrors. And it's actually our one of the newest products that we designed and produced here in-house, and we are very proud of it. And the customers, uh, it's going like hot cakes, luckily, because they love it. It's actually David's design and idea, and I'm really happy with the. I'm like a small kid, probably also the guys. I can speak in the whole name of the whole team when we get the fresh CNC machine part, and when it comes from the powder coating, this is the only thing that we don't do in house. We are like small kids to finally hold that product in the hands, and especially when we mount it on the bike as the final product. That's always a celebration worthy moment, actually. And in this case, that those were the mirrors that we had it on the plate for the last 1 year, and we finally did it. And yeah, this is the video about to show the whole process from the 3D scan, then to the idea on the computer, and then eventually have it in a in a final stage that you can hold it in the hand and put it on the bike. Yeah.
Basically, it's a plug and play. It must fit in all the bikes. Those accessories.
Exactly, it needs to be plug and play. A tricky part is actually sometimes, for instance, the mirror should be a universal product, and it's so many bike models, and today we mounted those mirrors on on a specific Ducati bike, and we thought it fits, but there's again a small change. So the R&D actually never stops if you want to fit the products on the as much as possible bikes. We also diversify our products into universal, which the name already explains it. And then you have products like crash bobbins, which are usually meant only for one type or let's say one model of the bike and one brand, because it depends on the shape of the engine and the frame, and it's usually completely different from one brand to another. But some parts are, then we try to do some parts or to be universal, so you can, produce then and save costs and so on. Yeah.
So if someone wants to do an accessory for his own bike, he just come with the bike, your measure of the 3D scanning, and then you can produce by one piece, or it must be, or it's just under, I don't know, maybe catalog or something.
Yeah, if he has a lot of money, then yes. But joke on the side. Usually we don't do it this way, that someone comes and says a wish, I would like to have it, because it does take few days to design and create the first idea. But what we do actually is, a lot of people are actually offering their bikes and asking us, hey, can you use my bike to develop parts for this model? And then we, for exchange that they give us the bike, we give them parts for free. So both sides are happy. But it would be possible that people bring the bikes to our workshop and to design for them, but it doesn't go that quickly, and it's too I would say way too expensive to just do a product for them.
Yeah.
So we are honest and say usually, okay, we don't have that, but some companies that we know are offering it, so it's way easier to order there. But we are developing, or let's say our brand is famous for that we have a very strong fan base, since they follow us since day one, when we started from the garage. and they insist to wait for a year for in some cases that we develop finally parts for them, and they don't want to buy a competitor's brand, which is actually for us still unbelievable that we have such a strong fan base, and it gives us the motivation to develop even more products and faster.
It's yeah, no, it's been fascinating to see how the 3D scanning technology has as well evolved, and its impact on the motorcycle aftermarket. So looking ahead, I believe that the 3D scanning will continue to revolutionize the way I think your company design and manufacture the motorbike accessories. So, and now with the AI, I think the 3D scanning along with this, with the trend towards the customization, it's transforming the motorcycle aftermarket. So I think we are moving towards a future where the riders can have bespoke accessories, so they meet their exact expectations, leading to a more personalized and enjoyable riding experience. I think in your experience as well, it's really important because you can you see what is the important on for the new products as well. I think other topics. I think in the future we can see right now it's the all the how the 3D scanning it's being used along with the other technologies. So I can see the rapid prototyping, so improving the maintenance and repair as well. So we can, I think the repairing it costs less than it used to cost, so we can do our own products as well. And then I think I will see in the future we'll see the integration of these smart technologies. So the but I think the future of the motorcycle accessories it's really I'm looking forward to see it, and I think you guys
Yeah.
are very good are a very good new or a very good it's very good positioned on this trends on using all these technologies. So
Yeah.
thank you Rock, thank you David. We can start the I don't know if you have any other topics or you would say anything else, but we can move forward with the questions.
Like when you mentioned before for the future, what brings, I also imagine, you have a lot of restoration in cars and bikes is was always popular and is becoming even more popular. And I imagine if you have a crashed engine case or let's say cracked or broken, and there is no more, a lot of times it happens that it's not possible to get it on the market anywhere. So for, I don't know, 100 years old bikes, so with a 3D scanner you can actually if it's cracked, you can 3D scan it and replicate one to one actually a part. And it also in that niche, or let's say this industry, you can I imagine that the 3D scanner is helping a lot. We are not doing restorations, but just
Right.
came to my mind that it's probably very, very helpful. Yeah.
Yeah. Yeah. In the restoration, it's the scanner. It's pretty handful because you can gather all the geometry of anything and then reproduce basically anything with the
Mm,
scanner. So we have a question
exactly.
here from Nelson. What CAD software have you used for the developing of your parts? So also, what 3D printing materials are you using in your prototypes?
Yeah, okay. For start, we use Pil 3D Pro. That is program with which we scan all our parts which need to be scanned, and then later after that we export them to Solid Edge. We use Solid Edge um, Solid edge. And what was the next question? Which material we use
Your
for
prototype.
for prototyping? We mostly use ASA filaments because they are very easy to print and they are not so expensive.
Yeah.
So yeah, solid edge and ASA.
So, along
Yeah.
with the PO scanner with the software as well. So how
Yeah,
much?
yeah, of course.
The next question I have here: how much time did it take it for you before you use the 3D scanning technology and to take the measurements to develop the product?
Yeah, like we said before, it depends on the part which you are developing. For example, last time we were speaking with Rok regarding sub cages, if I remember correctly, Rok. Um, in all the days, we it took roughly one week to measure everything and transfer later in the our CAD system. It means 1 week
Yeah.
for measuring and to be sure that everything is so it need to be. Uh, and now we use 3 hours basically. It means for scanning and for preparing the scan, 3 hours stop basically. It means roughly 2 hours for that. In comparison with previously 1 week to now is that improvement.
Yeah, yeah.
Uh,
I could say it helps you a lot in the
yeah,
safety.
definitely. Yeah, yeah, yeah.
And
The owners must be proud on us because we use so little time for developing now.
the next question is what's the most challenging accessory that you have designed and why?
Hmm.
I would say lately we are struggling a bit with because it's a very complicated thing to develop is the double brake system. That's actually a rear brake on the stunt bike. You have three brakes on one disc brake, and because they are different shapes and different, so is radial, the other one is axial, and to meet the disc brake in the middle of the, so all three calipers align, that's a very tricky thing to manage. And we actually did 5 prototypes without the 3D scanner, and all of them were wrong. And we spent a lot of money to make them, and then luckily we could save them and correct the mistakes. But now we did the new one with the 3D scanner, and it was not right away correct. It wasn't the mistake of the 3D scanner. It's just we needed to change the to align that all the calipers are the same system. So we went with all radial calipers and not only brake calipers and not with an additional axial. So it's a pretty technical thing, but anyway, so eventually it was way faster done than before, and with the 3D printer we then printed the prototype, and we saw that it's everything is in the middle. But it gives you that feeling that you can fit the calipers, on the disc brake, and you see how it actually works on the computer. Before it was kind of a guessing game. Yes, you can measure it with with the tape and so on, but it's never 100% because the for the disc brake there is only 5 millimeter space uh, where the disc brake can move in the caliper, and it doesn't have. So if you go 2 millimeters wrong, it can hit the caliper, which happened to us. So with the 3D scanner, we were way more precise, and that was one of the trickiest parts that we were developing. Yeah.
Thank you. I don't think we have any other question. maybe for question for David, the what was the feature you like the most on the Pew 3D scanner?
Which feature I like the most? I guess dark mode. Dark mode feature. Yeah, it's truly a game changer in regarding of scanning black surfaces or shiny surfaces. So the peel offers us dark mode scanning feature which you can click and you can scan every black surface, every dark surface without sprays, only with targets, and that is incredible. If you consider, for example, if you consider that we borrow, I don't know, bike worth 30 or 40,000 euros, and you spray all over it with paint, that is uh, the owner not gonna be happy, definitely, and I'm not gonna be happy because I need to remove all those white surfaces that powder basically, and yeah, dark feature was impressive. And even cooler is that during the scanning, you don't need to pause scanning or something. You just switch it between dark mode and other modes you have over there, and that is that is amazing. Yeah, that is one of the most impressive feature in.
It's basically it's just the scanner is just adjusting. We are talking about the shutter speed and how we can adjust to the scanner to the color we are scanning. And for dark parts, we with the PO3D scanner we don't need to use any powder because we can adjust to dark uh, parts, and then uh, we can change back and forward. It doesn't. We don't need it. We don't even need to stop the scanner. It's just on the fly.
Mhm.
I don't think we don't have any other questions. So I would like to thank you all, to thank you for being here to listen to us. Thank you, David. Thank you, Rok, and thank you everyone to be with us today. I think I'd like to say thank you, and I hope you enjoy this session.
Yeah, thank you also from my side. Yeah, the experience with 3D peel is amazing. So guys, you need to try it.
Thank you, Rok. Thank you, y'all. And let's stay tuned for the next webinars. We are trying to do our best to create new events like this. Thank you. Bye bye.
Bye.